That's how you sound, by the way. If I say y equals 5 minus 4x, can anyone tell me what the slope is? I haven't said anyone's wrong, but I haven't said anybody's right. So you can keep on guessing. Anybody else have a guess? Yeah. The number in front of the x is the slope, right? So negative 4 over 1 is the slope. And the 5 would be the y part of the y-intercept. I like it, right? So that's what I mean. They have a plus bx instead of ax plus b. They just, for number 8, they just turned it around. It's kind of silly. mx plus b. You got to know mx plus b. Okay, let's see. Let me record some of this stuff on my sheet. Oops, sorry, dude. Stop it. Up. All right, let me write some of the stuff down. Do this again. There it is. All right. So I got a slope. So what do we get for r? We got 0.738, basically, right? Is that better or worse than the one we just did earlier? So like stronger, right? That's what I really mean. It's stronger. I'll tell you what it's got to be. Let me see if this makes sense to you. The smaller the sample I use, the larger that has to be to show evidence that there's a relationship. So I will tell you the number. I'll tell you R has to be greater than something. I'll tell you what that is. Do you understand? So in this case, I think I remember it had to be like 0.456 or something. It had to be bigger than 0.456. And this is definitely bigger than that. So there's evidence of correlation. There's evidence that these are correlated somehow. Do you guys understand? So the closer it is to 0 in general, the worse the correlation, or maybe there is no correlation because it's below the threshold. The closer it is to 1 or negative 1, the stronger the relationship, the tighter it is to the line. I like it. So the graph is bad boy. Let's see. What do I get for the, there it is. So is this a strong correlation? Yeah, I'd say it's decently strong. What kind of correlation is it? What do I mean by that? Well, is it positive or negative? Positive. Positive correlation. Don't worry, I'll switch it over here in a second. What's the equation of the line of best fit? It'll be 0.66x plus 70.97. Just to round it off a little bit. Alright, so now if I go to y equals, I can kill this old line. It's no good. It's for the other data. And I can put the new line in at 0.66x plus 70.97. Now if I hit graph, I get crap. I get one little point, yay. I got a lot more points than that. Holy shit, I put a lot of stuff in there. So what did I forget? Zoom. I like zoom. For most of you, it should be 9. But double check to make sure. There might be more stuff in your zoom list. So that looks about right, doesn't it? And you can see why it's 0.73. It's decently strong. Everything is going in that direction. But it's not like 0.8, 0.9, 1.0 because the points are kind of a little far away from the line. Yes, ma'am?
How big can R get?
It's got to be between negative 1 and 1.
Okay.
That's it. Because negative 1 means perfect negative correlation. Can't be any better. Positive 1 means perfect positive. 0 means no linear correlation.
What does R stand for?
It stands for the correlation coefficient or the Pearson product. That's a lot of different things. Of course, my teacher's name was Pearson, but he had nothing to do with it. He liked to pretend he did. Sorry, Miss Pearson. As if you watch this. Let's see. So one big reason why we make these lines is so that we can make predictions. So if R isn't big enough, isn't far enough away from 0, I'm not going to trust the line. My best guess for anybody would just be the average, right? But here, this one was really good. This one was 0.737. It was higher than what it had to be. It's correlation. So I could use this line to make a prediction. So what if somebody studied for 13 hours? What would you predict for them to make? How could you do that? Well, 13 hours of study time is which variable? X. And it's 13. So what would you do? Plug a 13 in for X. It's crazy. There's a relationship you've created between Y and X. And Y and X have physical meaning. X is the number of hours somebody studies. Y is the grade they make on the test. So what would you predict for somebody if they studied for 13 hours? You just plug a 13 in, right? So you could do it this way, the old-fashioned way. 0.66 times 13. Do you guys see what I'm doing? Just plugging 13 in. 0.66x plus 70.97. There you go. 79.55. Nothing wrong with that. What's that? Oh, anytime you are in a screen you want not to be there, you hit second quit. Second mode, really. See the quit up there? It'll take you back to what I call the home screen. This beautiful, the printing screen. So if I hit clear, it will be the same. Yeah. Now here's a little tiny bit of a shortcut. If you go to see where it says calc up here above trace, go to calc value. I want to calculate a value. If I choose this value, it'll say, what do you want X to be? Well, I want X to be 13. So then it tells me Y is 79.55. Right, that's nice. I mean, it better be able to do that shit. It costs $100. Okay. So if they use the line of best fit to make a prediction, would you trust it? Yes, I would, because there was evidence of correlation. The closer it is to 1 or negative 1, the more I'm going to trust it. All right, baby. Okay, so let's do this. First off, I want you to realize something interesting. Do you remember those problems in algebra where they said, find the equation of the line? Goes through 1, -7, and 4, 2. Remember those problems? Pretend like you do. If you go, this seems kind of silly, but if you only put 2 points in, so clear list 1, clear list 2, and you put in there, let's see, what I put, 1, 4. See, those are the X pieces. And then I put in the Y pieces. -7. And 2. You guys with me? Now listen. If I plot 2 points, how many lines can I draw through that? 1, thank you. Straight line. Okay, well I could do this. No. Right? This is one straight line I can draw through that. So R, if I put 2 points in, R is always going to be 1, or -1 if it's negative slope, right? Okay, I like it. Then the third point, if I put a third point, then it could be all like, I don't agree. Right? Okay. So if I go do my stat calc number 4, R is 1, but it actually finds the equation. It's crazy. There's 3x minus 10. How did you have to do it way back in the day? Sort of. Y2 minus Y1 over X2 minus X1. Yeah, so 2 minus -7, so it'll be 9. 4 minus 1 is 3. You get a slope of 3. Bang. And then you got your good old Y minus Y1 equals M times X minus X1. Right? Plug all that shit in there, you eventually get 3x minus 10. Oh boy, bring it back. Bad memories. Good? All right. So let's do this. Last thing for today, and then I'll let us out a little early. See if you guys can help me. Let's do it. Let's say I want to make a set of data, create a set of data where the R will be big positive. I want the R to be big positive, right? Do you understand what I'm saying? I want R to be like 0.9, something. So let me start us off. Let me see if you guys can get this. If I put a 14 there, and I want R to be really strong, which means what? What's going to have to happen with the points? They're going to have to do what? If I want R to be really close to 1, the points for 1, they're going to have to go up. I like it. More importantly, they're going to have to...
Very close to each other in the line.
They have to be close to the line, so they have to kind of increase at the same rate. They have to have almost the same slope between each of them. Does that make sense? So if I go 14 there and then 18 there... Now, if I want it perfect, but let's say I don't want it perfect, I want like 0.9, so maybe we put 21. And then I'll add 7, and then I'll add 3. I mean, do you guys understand what I'm saying?
Yes.
And then go back to adding 4, add 4, and then finally I'll add 3. Let's see what happens. Go ahead and put that in and try to do everything we just did. And see how close I got to a decent, like a 0.9. You're so fast, man. Let's see if she's right. You're okay. You just did that so fast. Try to get it all the way to the point where you got the points and you got the line of best fit. No way. Nope. This is what we did earlier. All right, so if we do stat calc number 4, yeah, so we do get 0.996. Cool. So this, even though it's a relatively small sample, that is damn good, right? So I would expect something like the growth of fish over time, of course up to a certain time. Thankfully it doesn't just keep growing and it's the fish that ate Manhattan or something, right? But for a certain amount of time, humans, fish, trees, whatever the hell, we have a pretty linear growth pattern. And then, of course, we have some growth spurts, but it's pretty linear. And then, of course, thankfully, we taper off when we're not that old 50-foot woman, whatever. Right? You guys with me? So, one thing I want to make clear about this is these correlations only are true within the range of the data that we're using. So I couldn't make a prediction for this at 9. Because it's beyond the range of the data. It's sort of like, well, let's look at what the stock market did for this stock, and I'm going to buy tomorrow, and then you're dead. You can't assume it's going to continue on that trend. We don't know, right? Maybe this is the last time this thing grows, and it just stays 42 until it starts to shrink, of course, like humans do too. Is that cool? Understood? Okay. So when you go to graph this, my slope is 4.12. And my y-intercept is 9.96. That's neat. Sorry, it's neat because it's almost the same as r. So 4.12 x plus 9.96. And then if I hit graph, of course, I made the same stupid mistake, right? Hit zoom, 9. So that's why it's such a strong relationship, because the points don't get very far away from there. I like it. So that's really nice, I would hope. Now, just to warn you, what we just did is chapter 12, right? I should keep myself straight. Yeah. Chapter 12. And chapter 12.1 is a little review of linear equations. 12.2 is just scatter plots. Can you plot X and Y points? And then I take us up to 12. What was the thing that makes you? 12. Shoot, I can't remember. What was the other assignment? 12.1, 12.2? So we got your homework sheet? 12.3. And that was it? 12.5. Okay, good. 12.3 is where you get the equation, and 12.5, I think, should be, they talk about, 12.3's also got R in it. And 12.5 is where you plug stuff into the line of best fit to make a prediction. So they just broke out, everything we did, they broke it out into all the different sections. They seem to like to do that. Okay. That's plenty. Next time we'll get into chi-square distributions. Oh. Is that the right example? Oh, it is zoom set, okay. And then your scatter plot is turned off.
All the time?
No. I don't know why it turned off. It should stay on now forever until you turn it off. So now you do zoom 9. Yeah.
Okay.
Cool. Sure.